So let's get started. If you were here yesterday, which almost all of you were, you will find most of this very familiar, okay, because we did it yesterday. This is just almost exactly like yesterday, okay? So if you understood that AROC formula, good to go today. And if not, hopefully by the time I'm done teaching it again, you'll understand it. And you might notice the homework assignment up here is a lot shorter. It's like 6 problems, right? 1, 2, 3, 4. Yeah. I made it really short because I don't think we need to do the AROC formula 500 million times, okay? But just as I always say, I'm just reminding you of all these things at the beginning of the year until we just know it. Even though I don't assign them all, there's more there to practice. So if you're not feeling confident about it, do some other ones and check the key on Canvas, because I do always post the entire key, even if I don't assign them. Okay? Good? Yeah? Okay. I feel like you guys hate me today. No one's talking to me. No one's smiling. We're okay? Everybody all right? Nothing we need to talk about? Okay. All right. So make sure your phones are away. Please don't let me see them out. I am putting that thing back up. Okay. So, suppose an object is launched upward from a height of 120 feet with an initial velocity of 48 feet per second. The height of the object t seconds after its launch is given by this formula. So, again, we talked about this the other day, I don't know what day, but the 48 and the 120 are kind of distractors. They're just explaining the formula. They're built into that equation, okay? So, this first question, find the average velocity in the first 2 seconds after the object is thrown. So you've seen where it says t is 0 and t is 2. You've seen it written like this. Get comfortable, and I'll keep pointing it out in these examples, of the different ways you could be given the interval. Okay, we had the weird less than or equal to symbols yesterday. We'll see that again today as well. So understand average velocity. This is our AROC formula. Okay, and so it's just to make sure you guys understand it. AROC is just like your slope. We're just writing it a little fancier. It's your change in y over your change in x. So we're going to find what the y values are when the x values are these in a second. But let's go ahead and write the formula. Oops, that should be an h. All right, that's an h. So h of doesn't matter which one you put first, right? It doesn't matter. You pick, but remember, whatever order you put it in there, it matches it in the denominator. Okay, so if I put 0 first on top, 0 would be first on the bottom. And remember, h of 2, what that means is, what does y, right, h of t is just y. When I plug a 2 in here, what do I get for y? So these are y values right here, okay? It's a fancy way of writing a y value. So I'm just going to find a little space over here and plug 2 in, because I don't know what it is. I don't have a graph to look at. I don't have a table of values. All I have is an equation, a function. So I'm just going to plug it in. And let me be proper. H of 2 equals negative 16, and we're just plugging a 2 in everywhere we see a t. And you don't have to do this in little pieces like you might have done in other classes. Remember, I want you to use your calculator. I want you to feel comfortable with your calculator, okay? There's parts of my test, parts of the exam, the AP exam, that are calculator yes and calculator no. This is a calculator yes part of the problem, or part of your test, whatever. So I'm just typing it in straight as I see it. That's 48, 2. Just take a second and, oops, see, okay, look what I did wrong. So if it happens to you, I didn't move my cursor down, okay? Some of your calculators do it automatically for you, some of them don't, okay? So let me go back. So when I go to square it, see how my cursor is up in the air? I have to move it down by just hitting the right arrow. It just moves it to the next place, down on the ground, okay? So plus 48 times 2 plus 120. So I just typed it in, left to right, hit enter, and you should get 152. Okay? So anytime I go over a calculator thingy and you're not getting it, I went too fast, you weren't listening, whatever the reason is, when I come around and help, just ask me to come over to you and I'll show you one-on-one, maybe what you're doing wrong or whatever you're missing, okay? But you should get 152. And then guys, don't overthink this. I'm going to write this one time. You don't need to write it, but I keep seeing people plug this all in. If you're going to plug a 0 in for these variables, all that happens to those terms is they become 0, okay? There's no reason to write that out. when I plug a 0 in here, I just get 0. When I plug a 0 in here, I get 0, and I'm just left with the constant. That's the number without a letter. So it's just 120. You don't need to do the work. Just cut some corners where you're allowed to. Okay, so I do 152 minus 120 in my calculator, divide by 2, and I get 16 feet per second. Okay. And there's another one here. I don't feel like we need to do another one. It's exactly the same thing we did for this one. It's just h of 4 minus h of 2. We have plenty more to do in the notes and in the homework, so you understand it's just the same thing. Yeah, sorry. Okay, you need to go now. It's fine. I usually don't like you guys go during notes, but just go real quick, okay? Because we're going to do something kind of new right here. I hate for you to miss it. Okay, what I want you guys to do, if I haven't told you how to clear your RAM, that clipboard right there. Yep, that's it. Clear your RAM. I wrote it on the calculator tip sheet at the bottom, but this is something you're going to want to do all the time, so you'll probably memorize it, okay? And remember, what this does is gives you a clean sheet of paper. Did we talk about that before? Okay, I know there was one class I didn't. It's so hard when I do this 5 times a day. There's always somebody I forget to say something to. Okay, so second plus, and you don't have to even wait. You can do it really fast. It's just second plus 712. And the more you do it, the more you'll remember it. And it is such a smart idea. When I come around and help people and they're having problems with their calculator, that's the first thing I do. And usually clearing the RAM solves whatever ails your calculator, okay? So you just want to see RAM cleared, and that just takes out anything anybody has done to it. Because we're going to graph 4 graphs right on here to answer these questions. Life is good when we have a graphing calculator, seriously. Okay, so what they're asking here is, for each of the following functions, they're giving us 4, describe the average rate of change, which is just your slope, okay, we can think of it in what we're comfortable with, slope, over the given interval, so that's the x values, right, interval is from here to here on the x-axis, as positive or negative, meaning, does it have a positive slope, or does it have a negative slope in that section of the graph? We don't have to actually plug numbers in. We could absolutely do all of this work and see if we get a positive answer or a negative answer. Who wants to do that? Let's do it like this. So remember how to graph, or I'll teach you if you don't remember. So y equals top left, and then we type in the x, which is right next to alpha, to the power of 2. That's it. You type in what you are going to graph and hit the graph button. It's a parabola, pretty basic parent function parabola, and understand what the question is asking us. From 2 to 3, which are over here, part of the graph, what is happening? Would this be a positive or a negative slope? Can you guys tell just by looking at this? Positive. It's positive, okay? But just for fun, let's say you couldn't tell because it was too zoomed out. This is a great time to kind of play with your zoom button. It's right in the middle. And on that calculator sheet, I gave you there's a box in there. You have to find it. One of the little boxes on the calculator tip sheet I gave you. It explains what each of those mean, but it's kind of fun to play with them. Like if you go to zoom in, like number 2, and hit enter, it just zooms in closer, so you can kind of see it a little better. And you can kind of play with it. Zoom decimal, I don't know what that is. I don't know what that looks like. Zoom square, but it explains it to you. So it's kind of nice to play with it and just see what they all are. But as you guys said, we can tell all of the numbers greater than 0 are going to give us positive slope, right? It's rising, so that's what that means, okay? So let's do B. Back to y equals, and you can just hit clear. Your clear button is right here, and it just gets rid of that. And let's type that one. So your log, look for the log button. It's next to the 7. Okay, log right there. And we don't have to know much about logs right now. I mean, I know you touched on them or did them in Algebra 2. We'll touch on them later again. But the calculator is going to do the work for us. We're just analyzing the graph. Hit graph. And again, you can zoom in if you want to. So just hit 2, enter. And it gets a little bit closer in. But do we really need to get much closer? What's happening from 0.1, which is right there, it's there. It's right here. It's going like this. That's also positive. Do we see it? Good. Okay. Back to y equals, clear. Now, if you're going to, this is important, if you're going to put this in as a fraction, like exactly like it looks, you have to use parentheses. That's a lot of buttons, but I see how fast you guys text, so it's probably not a big deal to you. But the point I'm making is, if you don't want to deal with the parentheses, you can just use 0.5. It's the same thing as 1/2, okay? To the power of x, graph it, and it wants to know from, now what the heck am I seeing? I'm on some weird Zoom right now, right? Let me see, did I type it in correctly? I sure did. So let's change our Zoom. So back to my graph. Let's do Zoom. Why am I getting this weird Zoom? Zoom out. So let me just show you what I would do in real life. This is real life. I'm not liking what's going on here. I've been playing with my buttons. I might clear my RAM again. Second plus 712. Once you learn it, it takes seconds to do. Then I might say, okay, let me start this over again. 0.5 to the power of x, graph it, and you can see it fixed that problem really quick. It's faster than finding all the mistakes or what did I change, because trust me, there's so many things they're going to learn, like ways to change how the x-axis and y-axis are counted, how to change where you like look at the graph, like your viewing area. So sometimes just to clear it, clearing the RAM solves the problem. Okay, so from -1 to 0, right here, from -1 to 0, what's happening there? As I read my graph left to right, remember, that matters. We read a graph from left to right. So from -1 to 0, my graph is going down, right? I'm decreasing. That means it's a negative slope. Yes? Yes. So she's saying if we had done this parabola right here, it asks for negative numbers. Let's just do -3 to -1, like you said. That would be, so here's your vertex. It'd be over here. So these would be negative. And that's actually going to come up in one of our examples. Last one, back to y equals, clear, 5 minus 2x squared. Get comfortable with the buttons and where to find them and how to put them in. You guys understand the words I'm saying, of course. You know what I'm saying when I say 5 minus 2. You understand that, but get used to being pressing the buttons, right? So graph, this is going to be another parabola. It opens down. We want from 1 to 4, left to right. That's why we always do interval notation left to right. So from 1 to 4, that's going to be anything over here, right? We don't even need to zoom way down. We know with a parabola, this is just going to continue going down, down, down forever. So our graph is decreasing. That means a negative slope, okay? So just some fun with the calculator, not having to do it all by hand. Okay. Example 7. Let R of t be the altitude of a rocket. T seconds after launch, write an expression, there it is again, we had one just like this yesterday, for the average velocity of the rocket. Oops. So here they're giving us T equals and T equals, instead of putting it in like this notation, right? Same idea, we just read it the same way. So don't let the H bother you. Sometimes we create an expression, an equation, a formula, that we can plug anything in for H. It's just adding to the 5. So maybe I want 7, so it would be 5 plus 2 or whatever, okay? Don't overthink it. Don't think, oh my gosh, now there's an H in my formula, what do I do? So our A rock would be R of, and you can put either one first. I'm going to stick with always putting the bigger one first, but if I add anything to 5, unless it's negative, I guess. So it doesn't really matter. Right? I just followed the same rules. Who cares that one of them had an H? And remember, when it says an expression, there's no other information. I have no other things to plug in. The only thing I would want to do is simplify this if I could. And you normally can simplify the denominator just like we did yesterday. So this is R of 5 plus H minus R of 5. Can't do anything with those. But Guys, this is the same as saying 5 plus h minus 5. The parentheses aren't really necessary. You can combine any like terms. That is the same as saying 5 plus h minus 5. It means the same exact thing. So the 5's cancel, we're just left with the h on the bottom. And that's all we can do. Okay? And this is our last real math we have to do. There's just one more example I'm just going to talk about, give you the answers for, and then we'll talk about, but this is the last one we just have to do a little bit of work. Okay, so given this equation of a parabola, they happen to give us the graph as well. So we have this in two forms, graphically, picture, and algebraically, an equation. Find the AROC of the function on these intervals. Oh my gosh, how many times are we going to see this? Okay, so let's do the work for one of them, and then I'll give you the answer for the other. All right, so same old thing we've been doing. You decide who you're going to put first. And you can do F of anything. You can use any letter. If they don't give you something to use, like R of T or H of T or whatever, you pick what letter you want. It doesn't matter, okay? So I'm boring. F of 1 minus F of negative 1. Order doesn't matter. Over 1 minus negative 1. Same old AROC formula. Now, you have two choices here. This is actually a really nice graph, and I only know this because I just did this problem last period. I can use the graph to find what the y values are at 1 and negative 1, because they cross at nice places, okay? If I didn't have this graph, or it looked like it was a decimal, like in between, like the crosses, I would have to use this. This is easier, though, right, than having to do the plugging in a 1, plugging in a negative 1. So we're happy they gave us a nice, pretty graph. So I'm going to use that. And so at x is 1, y is 2. So f of 1 is 2 minus f of negative 1 is 6. Okay? You would have gotten those same answers if you had plugged those numbers in there. Same thing. Okay? And then 1 minus negative 1, remember these two cancel, we get 2, which is negative 4 over 2, which is negative 2. Okay, so the answer to this one is negative 2. I'm just going to put it there since I used all that space. And I did the work for you on this one. Okay, same work, f of 3 minus f of 1, plug them in, and here's the answer to this one. It would be positive 2. Okay, so positive 2 for this one, negative 2 for this one. Everybody good? Yep. Okay. Describe the relationship between the rate of change and behavior of the function. So what they're saying here is from negative 1 to 1. That's the first one we did. Let me zoom in. From negative 1 to 1, that's this piece right here. What's the connection between a negative number and that graph? We're decreasing. So our rate of change or slope should be negative. They go together. I don't know how many more ways they want us to say it. But here's a way to write it out. So on the interval of negative 1 to 1, that's the one we just found, the rate of change, we can just write rate, is less than 0. Guys, that's code for negative. Less than 0 means negative, right? We got a negative rate right there. And the function decreases. Function decreases. Roller coaster going down. And of course, I didn't make you do the work, but trust me, I did it right. On 1 to 3, which would be from here to here, this part right here, it makes sense that we got a positive answer, right? Because it's increasing, going up the roller coaster. Our rate is greater than 0. Code for positive, right? Fancy talk for just negative and positive. And the function, what? Increases, thank you. Okay, I really want you guys to make that connection, all right? Last part of this one, how would you describe the rate of change at x equals 1? So now that I've written all over this, x is 1 is right here. So I'm going to put a big X there. Okay, is that decreasing or increasing at x is 1? The answer is neither. That's where your turning point happens, right? So a turning point is where you change from decreasing to increasing. You're neither decreasing or increasing. That's your change of direction. So you could say at x equals 1, the function has a turning point. And let's take it one step further. At a turning point, guys, even though I said it doesn't have a slope that's decreasing or increasing, it actually has a horizontal slope of 0. It's neither negative or positive. Makes sense, right? It's right in the middle of the negatives and the positives, is 0. Okay? Good? Okay, just one more idea to talk about, and I'm going to give you the answers to it, and then we'll evaluate it. Actually, I don't think we need to do that. Yeah, we do. Okay, so turn the page. You done here? Nicole, put your head up, hon. All right, we're not doing that one. That is ridiculous. All right, so what I want, so I really just kind of want to talk about this one, because this right here is something I need to make sure we understand, okay, without doing a whole bunch of work. They give us an equation that talks about the traffic flow at a particular intersection, okay? It's got a sign value, the word sign. And we can plug numbers into this equation. We can use our sign button. We don't have to know much about sign. We can use the button here and get some numbers and answers, okay? So, and we could do this interval from 3 to 8. Oh, I did want to talk about this. This question is asking for you to find the AROC, okay, from 3 to 8. And it's just written that other way. We've seen it so many different ways now, okay? So just be able to recognize what your x values are. So that's another example of 3 to 8 written like that, or t equals 3, t equals 8, lots of different ways. So what this is talking about here, which I have to talk about with you, is it possible to find the rate of change at a specific time? In other words, if I said, what is the traffic flow at 5 minutes? Not between 5 and 7 minutes, but right at 5 minutes or right at 7 minutes. And so let's pretend that we can. The answer is no, okay? You cannot do that. And here's why. Let's pretend that I said, okay, I want to know how the traffic flow is at 5 minutes. So from 5 to 5, right? That's really the only way you could do it. When I plug that in, what am I going to end up with in my denominator? 0. That is not okay. We can never have a 0 in our denominator. That's why these are called average rate of change. We can't get an exact answer, okay? Because by definition of the formula, we would have a 0 in our denominator, which is undefined. So one thing I want you guys to take away from what I'm saying here is that we can find the interval between any two x values, right? Any two x values is fine. But the closer they are together, the better and more reasonable your answer is. So, for example, well, no, I don't want to get too deep in that. But if we wanted to know at 5, we might do from 4 to 6, and that would give us the closest versus from here to here. Okay, the closer you are together, the more exact you get. All right, but you cannot find an average rate of change at one particular number for that reason. Okay. All right. Homework. There are a lot of pages in 1.2 practice set 2. A lot. There's a lot of problems. Even though it says 14 to, it's actually much longer than 14 through 20. That's a typo, I think. But I'm only requesting these. And I think they're all ones we should be able to handle if you understood the notes. But I'm here for you. You can work together, of course. Please write it down, and then I'm going to work my magic with my trying to post these up here. Ms. Shackton taught me something, so I'm going to try it by using both screens. So once you guys write the assignment down, then I can move it. So make sure you please try to do that right at the beginning. Everybody have it written down? You have it written down? Somebody's still writing. Good? Okay. So
14, 16. Okay, so you should have this 14. There. It takes me longer to do this than it does to teach the lesson, I swear. Okay. These. And then I can do so this is now going to be over there. Let's see if it works. You guys can tell me if you like it or not. And then I can do this. So if you have to move your seat to see, I totally understand. So that gets us up to 24. Okay. Oh, did I show them all? 14, 16, 17. Okay. They're all up there. You might have to move. Sorry. If you need to, I'm okay with it. Talk to each other. Ask me for help. Don't be shy.
I guess what's important to me is that you know what that means. Like what I'm I want to, at least whatever that That was exactly right.
thing from negative 7 to negative 2, which is the same as from A to B. Okay, so we're going to do and what is the y value? And here's point out the graph. Here, we don't know the graph, but that is so we do that. Okay, sorry. This is saying this is only a problem. So it's not like this is a real life problem. So it only goes from 1 to 4. So the question is, what is the price? So why is it? Okay, that's really okay. What all of these.
Okay, when you're on 17, it's telling you that the catnip treats prices vary from $1 to $4. You want to know what the price increase is from 3 to 4. So you're finding C of 3 and C of 4, not 1 and 4. Okay? That from 1 to 4 is like the don't eat restriction. It's the only prices you can have of those treats.